Good morning, students. Today we are going to start a new unit, that is aldehyde, ketones and carboxylic acid. These class contains an important functional group known as the carbonyl group. The majority of biologically important compounds contain carbonyl group. Students, these are widely spread in plants and animal kingdom and play an important role in many biochemical processes. They are used in many food products, pharmaceutical agents, and synthetic materials like plastic, fabrics, paints, perfumes, adhesives needed in our everyday life. Benzaldehyde is one of the major components of the almonds which we take, right? So from today we are going to start this unit, that is aldehydes, ketones and carboxylic acid. And students, first of all we will discuss aldehydes and ketones. Now the carbonyl oxygen. Now before we start the aldehyde and ketone part, now first let's know about the carbonyl group, though it is not unknown to you, but then also carbon oxygen and carbon carbon double bond differ in major way. A carbon oxygen double bond is polar and carbon carbon double bond is non-polar. The electronegativity of oxygen is 3.5, which is much greater than carbon 2.5, and hence student, the carbon oxygen double bond is polarized. The oxygen atom acquiring a fractional negative charge and a carbon atom acquiring a fractional positive charge. Now this is clear that a carbonyl group is a polar group, right, where we have the difference in the electronegativity between carbon and oxygen. As a result, charge separation will take place. Now students, compounds containing carbonyl group. Now here we are going to discuss about the aldehydes. Now in an aldehyde, one of the two additional bond that the carbonyl carbon atom form must be to the hydrogen atom. The other may be to a hydrogen atom, an alkyl or a cyclohexyl group or an aromatic ring system. Right, so we have got HCHO, that is the one bond will be with the hydrogen and other can be either with the hydrogen or it can be with the alkyl group or to the aryl group, right? Now the second compound which contains the carbonyl group is the ketone. In ketone, both the additional bond of carbonyl carbon atom must be to another carbon atom that is a part of either alkyl group or a cycloalkyl or a aromatic group, right? So it can be either to both carbon atom like simple ketone CH3 and CH3, or it can be either to the one two different alkyl groups, right, or it can be to a cyclohexyl group or it can be to a aromatic ring also, right? And the compound containing a carbonyl group, another one is the carboxylic acid. In a carboxylic acid, one of the two additional bond of the carbonyl carbon atom must be to a hydroxyl group and other may be to a hydrogen atom, an alkyl or a cycloalkyl group or an aromatic ring system. The structural parameters for a carboxylic acid are same as those for an aldehyde, except that mandatory hydroxyl group replaces the mandatory hydrogen atom of an aldehyde. Students, other than this, the carbonyl group can be also be present in the acid derivatives like acyl halides, acid anhydride esters and acid amides. But in our syllabus we have aldehydes, ketones and carboxylic acid. Student, aldehyde is a carbonyl containing organic compound in which the carbon atom has at least one hydrogen atom directly attached to it. The remaining group attached to the carbonyl carbon atom can be either an hydrogen. If that is the case, then it will be methanol, and if it is an alkyl group, it can be any other aldehyde, right? A cyclohexyl group or an aryl group. Now students, coming to the nomenclature for aldehyde. So students, whenever we name an aldehyde, first of all we have to select the parent carbon chain which is longest, which includes the carbon of the aldehyde group or the carbonyl group. Second one is to name the parent chain by changing the E ending of the corresponding alkane and name to al, al. Third is the number the parent chain by assigning the number 1 position to the aldehydic carbon atom. Fourth one is to determine the identity and location of any substituent and append this information to the front of the parent chain name. That is, if a substituent is present, will be along with its locant, we will just get it prefixed before the parent name. Now students, these are the few aldehydes which you have to name. So you will try to assign the IUPAC name to the following aldehydes. So students, you will assign the IUPAC names to the following aldehydes. Now students, nomenclature, unlike the common names for the alcohols and ether, the common names for aldehydes are one word rather than two or three. In the IUPAC system, aromatic aldehyde compounds in which an aldehyde group is attached to a benzene ring are named as a derivative of benzaldehyde, the parent compound. Now if you see here, benzaldehyde, benzene ring, and this has got the CHO group attached to it. The last of these compounds is named as benzaldehyde rather than as phenol because the aldehyde group has priority over the hydroxyl group in the IUPAC name. So when we are naming it, it will be 4-hydroxybenzaldehyde. Similarly, the next one is 3-chloro-5-methyl benzaldehyde. So they will be named as a derivative of benzaldehydes. Now student, next is a nomenclature for ketones. Assigning IUPAC names to the ketones is similar to naming aldehyde except that ending on is used instead of al. So first rule is that we have to select the parent chain, the longest chain containing the carbon atom of the carbonyl group. Second rule is name the parent chain by changing the E ending of the corresponding alkane name to on, and the ending on is pronounced as on. Now rule 3 is number the carbon chain such that the carbonyl carbon atom receives the lowest possible number. The position of the carbonyl carbon atom is noted by placing a number immediately before the name of the parent chain. That is, if the ketone is present, the carbonyl group of ketone is present at the second position, we will in the carbon chain containing 5 carbon, so we'll name it as pentane 2-on. Rule 4, determine the identity and location if any substituent is present and append this information to the front of the parent chain. If any substituent is present, then it will be prefixed the parent chain name. Now the next rule is cyclic ketones are named by assigning the number 1 to the carbon atom of the carbonyl group. The ring is then numbered to give the lowest number to the atom bearing the substituent. Now you can just apply these rules for naming these ketones. Now students, the aldehydes and ketones shows isomerism. The constitutional isomers exist for aldehyde and ketones, and between aldehyde and ketones we have functional group isomerism. The compounds butanol and 2-methyl-propanol are example of skeletal aldehyde isomer, that means the chain isomer. Compound 2-pentanone and 3-pentanone are the example of the position ketone isomers, right? That means aldehyde and ketones, they will show chain isomers and the position isomers. Ketone will only show the aldehyde will not show the position isomerism. Why? Because it is always getting the first position, right? CHO group will get the first position, whereas the ketone will show the position isomerism. Aldehyde and ketones, they are the functional isomers of one another, right? They both having the same formula, they will become the functional isomers of one another. Now here you can see that aldehyde skeletal isomers, CH3 CH2 CH2 CHO, and the other one is CH3 CH having substituent CH3 and CHO. Similarly, ketone will show students position isomerism, right? Now as I said, the aldehydes and ketones, they will be the functional isomers of one another, right? So what are the isomers shown by the aldehyde and ketones? Aldehyde will show students skeletal isomerism, that is known as chain isomerism. Ketone will show the position isomerism, right? And it will definitely show the chain isomerism also, and they both together shows the functional isomerism, right? So students, just go through this, and next we will discuss the preparation of aldehydes and ketones.